Busan, the best harbor city in Korea. In this energetic place, another history is now open. A dream for the core of physical distribution in Northeast Asia in the 21st century. Busan New Port, a stepping stone of the dream. A new port stands in the center with innovative technology. Container Terminal Development Project at Busan New Port Phase 2-3. Busan Port is suffering from chronic pileup due to increasing import-export cargoes as time goes on. In order to solve this problem, Busan New Port is being built with great aspiration in the area between Gangso-gu, Busan, and Angol-dong, Jinhae. Busan New Port is designed with a total of 30 berths, among which 6 berths of North Container Terminal are under operation. Phase 1-2 and 2-1 at North Container Terminal and Phase 2-2 and 2-3 at South Container Terminal are under construction in order. Phase 2-3 project, the key position thereamong, is the first automated terminal with a vertical layout. Hyundai Development Company and Boeing Travel Publics from France are working jointly among the landmark terminal of Busan New Port. Container Terminal at Busan New Port Phase 2-3 covers an area of approximately 840,000 square meters, which is equivalent to 120 soccer stadiums. Length of quay wall is approximately 1,400 meters, which allows 4 container vessels of 50,000 tons to berth at the same time. In addition, total project cost amounted to 940 billion won, is produced by pure private investment, including operating equipment such as 12 units of quay crane and 60 units of yard crane as container unloading facility. Quay wall of Container Terminal at Busan New Port Phase 2-3 is designed with caisson type. 62 caissons will be set throughout 1,400 meters of quay wall. Weight of one caisson is approximately 2,700 tons. 15 vertical slits will be put in the front of the caisson to improve calmness in the port. We also focus our efforts to securing the durable period for more than 80 years, as the caisson is exposed to seawater and sea wind directly. In addition, tensile crack is prevented through the mock-up test so as to prevent crack at slit column due to tensile strength of PC rebar, which may occur during caisson lifting with crane. Depth of quay wall is designed as DL 17 meters. For the sake of caisson setting, the soft ground will be improved with sand compaction pile with 71% and 34% of replacement ratio. As far as sand compaction pile is concerned, casing pipe with 1.2 meters of diameter will be pressed down to supporting layer using marine SCP equipment, and sand column with 2 meters of diameter will be formed on the ground by performing drawing and compacting repeatedly. After SCP, placing 5-meter thick rubble mound will be set and caisson will be set thereon. Then caisson back fill-in will be conducted with crushed stone. Finally, sand will be reclaimed and cap beam concrete will be placed to complete the quay wall. The site for Container Terminal at Busan New Port Phase 2-3 is developed through sand reclamation works. There is soft clay layer with thickness of average 40 meters and 70 meters for maximum at the bottom of the seabed, which causes settlement of ground in large amount. Therefore, ground improvement works are essential in order to build a port on the ultra-soft ground. To achieve the designed height by reclaiming the sea, approximately 6 million cubic meters of sand is required. However, about 12 million cubic meters of sand is necessary, considering the sand required for supplementing the settlement. The sand binded from the open sea 100 kilometers away is delivered by barge and discharged with water through discharge pipe to form the site. Ground improvement works are conducted by dividing into total 3 phases. After reclamation at Phase 1 area of 400 meters section first, PBD, the vertical drain board, will be placed down to 50 meters. All the removed sand will be reused for reclamation and preloading at Phase 2 and 3 areas to minimize the quantity of sand to be dumped. loader of container crane is supported by a caisson at the seaside and by steel pile pipe of 1,016 millimeter diameter at the land site. For drainage, 600 manholes and drainage facility will be installed. Container yard will be finished from 250 millimeter thick crushed stone pavement. Apron and other areas will be finished with asphalt pavement. The works are proceeded by dividing into two sections at the same time. In the first year, foundation of quay wall and channel dredging will be performed by ground dredger at quay wall section, while reclamation at Phase 1 ground improvement area, PBD works and preloading are conducted. Total 5 SCP equipment are mobilized to conduct sand compaction pile of 250,000 meters. In the second year, heaving soil dredging rubble mound definitive setting of caisson is backfilling of caisson and rubble mound works will be conducted in turns. After quay wall works are completed, reclamation and soft ground improvement works at Phase 2 area will be conducted. In the third year, rail foundation, drainage, building, and electricity works will be performed on the area where caisson preloading, cap beam, and ground improvement works are completed. In the fourth year, pavement and installation and trial operation of crane will be conducted. The core of container terminal is handling the maximum containers at the right time. Busan New Port is pursuing the best in Northeast Asia in terms of efficiency and operation, as well as facility and scope of the terminal. Especially, quay cranes is designed to be able to move between berths, which allows handle cargo speedily, and also to be able to endure strong winds of 60 meters per second, which allows safe operation during typhoon. In addition, total 60 fully automated yard cranes will be installed with 10 rows of 5 columns, and the terminal will provide capacity to handle 2,700,000 TEU of volume through 30 container pile blocks. When unloading the container, the former terminal had to go through a complicated process. That is, container is loaded on the trailer on standby from quay crane and is again transferred from the trailer to the yard crane. However, shuttle carrier will be induced in this port, and it can handle a container box from quay wall to container yard by itself. Shuttle carrier is unloading equipment using GPS and the core of automated system. That allows much more efficient and economic operation of port possible. Moreover, through establishment of efficient traffic line system for safety for vehicles passing the terminal, high-tech operation main building, which is the heart of container terminal and gate system, our port will be a core in realization of innovative terminal being ahead of our time. High-tech automated container terminal to be built in Busan, Newport Phase 2-3. Hyundai Development Company, a project designer that changes Korea, and Boeing Travel Publics, the first construction company in the world from France, are making every endeavor jointly to build the base of marine logistics with high-tech system and the icon of container terminal that the world will look in, learn, and admire. You can lead the future only if you look ahead and prepare first. Northeast Asia that rises rapidly as the center of the world economy in the 21st century. Korea will dominate as a new center of physical distribution in the world in the 21st century through the completion of the magnificent Busan New Port in 2011. Container terminal at Busan Newport Phase 2-3 is opening the secure foundation thereof.